Thank you for joining our presentation today titled Assuring the Future of the RAN. My name is Sean Kinney. I'm the editor-in-chief at RCR Wireless News. Got quite an interesting and expansive topic today that covers a lot of different pieces of technology and business strategy. Before we get into that, I've got a little bit of housekeeping that I'd like to run through here. First off, everyone that registered for this webinar will also be receiving a companion report that goes into a good deal more detail on some of the topics we're going to discuss today. And it's based on a number of interviews with carriers, vendors, and other ecosystem stakeholders. So look out for that in your inbox. Second, we're recording this session, so a video of the presentation will be available on demand and the slides will be made available to registrants. And finally, we've reserved some time towards the end of our session for question and answer. So please use the webinar portal to submit your questions throughout the discussion, and we'll get to as many of those as we can. Joining me today is Ken Sanfeld, president of Solid here in the US, and Ken's going to share Solid's perspective on Open RAN, what they're doing from a product standpoint around that, and what are some of the implications of the Open RAN movement to the in-building space. Before I hand it over to Ken, I'd like to set the stage a little bit and take you through some of the big trends around Open RAN. And I'll provide a little bit of commentary on how some major global operators are approaching the technology. Then we're going to go over to Ken from Solid, and then we will get into Q&A. So first off, what is Open RAN? Well, it's a set of technologies, but it's also a concept. And both of those things are all about flipping the paradigm of network economics from proprietary single vendor radio sites to a more mix and match approach of selecting best of breed, more IT type hardware, then connecting it all together via open interfaces and with software. So in order to do this, we need guidelines in place that will define how these different components work together. That work's being led by two groups, and we'll take a closer look at both of them here in just a minute. And another aspect here that we'll discuss more with Ken is the non-carrier users of Open RAN technology. As the 5G standard is refined in upcoming releases from 3GPP, we'll see support for ultra-reliable, low-latency communications. We'll see better support for massive IoT in addition to the enhanced mobile broadband piece that's commercialized currently. So these refinements will help take 5G into vertical industries of all types: CRE, mining, manufacturing, automotive, transportation. It's a long list. So the point is that the opportunity for this type of market development is most certainly there, but the current large monolithic systems associated with telco networks are likely not the best fit for this type of deployment, so we need something different. And then finally, virtualization at the RAN is an extension of trends we've been playing out in the core for some time. They're all about programmability and flexibility. But when you're able to build this end-to-end virtualized network that extends from the core all the way out to the RAN and however else you might define the edge of the network, the long goal is to enable network slicing. And there's a lot of revenue opportunity there associated with 5G, but you have to make some investments to get to that point. So why do we need all that? Not to put too fine a point on it, but network economics have to change. The sheer scale of 5G, the mix of users, the mix of deployment scenarios requires lower cost hardware. That's it. And the way this is playing out, we're seeing a lot of companies that are not necessarily the big five RAN vendors develop really strong niche technologies. So while it's not necessarily the entire stack that you might be able to buy from the big five, you are seeing best of breed hardware coming out of some of these smaller players. So as you see more innovation come out of various pockets of the RAN vendor community, this forces everyone else to focus on their core competency or otherwise drive innovation in their own product. Part and parcel of all that is the collaborative process that underlies it. You can't figure out how to mix and match hardware and software in a vacuum, so you have to work together through some consortia to make this happen. So this further drives a virtuous cycle of innovation and competition that itself feeds right back into the network economics piece. So at a high level, that's the why of Open RAN. So I've mentioned the consortia that are driving the development here. The O-RAN Alliance is certainly one of the leading groups helping define Open RAN. This group was formed in February 2018, and it is a combination of the former X-RAN Forum and the C-RAN Alliance. This is an operator-led organization, but it's constantly tallying new contributing vendor members. So since its inception, O-RAN Alliance has established 8 working groups, and those are focused on a number of different technologies, including open front haul interfaces, cloudification, orchestration, and white box hardware. Got all of them spelled out there on the screen for you, as well as a sort of a graphic of Open RAN architecture. So since these guys got started, those working groups have developed 18 specifications that cover everything from transport and application protocols to front haul control management and synchronization. And the membership's grown to include 22 operators and more than 100 contributing vendors. So if you want to kind of keep abreast of some of the developments in Open RAN, I'd encourage you to take a look at the O-RAN Alliance. The other big group here is the Telecom Infra Project, and this is a consortium that's led by Facebook, and it's centered on rethinking how telecom network infrastructure is designed and deployed. TIP's an offshoot of the Open Compute Project, and really the goal is to foster a consortia-type environment that's focused on making efficient, flexible, scalable network hardware based on the general premise that given data consumption and data creation trends, current infrastructure can't keep up in a way that's going to be affordable to the companies that have to foot the bill for deploying this infrastructure. So the aim is to create kind of flexible, future-proof network infrastructure. TIP hosts a number of RAN-related projects, and some of its members have taken this technology and actually commercially deployed it. To call out one, Open RAN, which is among the 6 technology focuses that you see on the screen, is all about defining and building 2G, 3G, 4G, and 5G RAN solutions that are based on a general purpose, vendor-neutral hardware and software platform. And just as a side note, TIP's having their big annual event next week in Amsterdam. So again, to kind of keep pace with this very dynamic area, I'd encourage you to follow the news out of the TIP show next week. So now I wanted to bring in some operator perspectives. I mentioned Open RAN on the previous slide. This is something that Vodafone is trialing in the UK, in the Democratic Republic of Congo, and then also in Mozambique. And those latter 2 are focused on rural connectivity. Also worth mentioning, Vodafone has conducted Open RAN testing in partnership with some other carriers in rural settings, particularly South Africa and some parts of Turkey. So the quote you see on your screen here is from Group CEO Nick Reed. "We're pleased with the trials of Open RAN. We're ready to fast track it into Europe as we seek to actively expand our vendor ecosystem." So there it is. Nick Reed immediately hits on that point of expanding the vendor ecosystem. And then in the next line, he goes right on to network economics. Maybe also worth pointing out that while the intent is to mainstream this technology across their multinational footprint, a lot of the real action is still centered on very much rural deployment. So take from that what you will. Moving on to the next slide, we've got Enrique Blanco from Telefonica. And, I mentioned earlier this idea of creating a cloudified network all the way from the core out to the RAN. And this is what Enrique is talking about, is designing and building cloud-based networks to keep up with the data consumption patterns from their consumers. To do that, the network needs to be open. So to get the capabilities that they need, they want as many options as possible in their vendor toolbox. And that's what Telefonica is actively working for. Maybe also worth mentioning that Enrique Blanco made these comments at a recent event in Zurich hosted by Huawei. And then just a few days later, Telefonica announced a fairly significant investment in Altiostar, which is, as you might be able to guess, an Open RAN vendor. So they're definitely putting their funding in line with their strategic roadmap. And so now let's come over to the US, take a look at Verizon. Just, I know we're all familiar with what's going on with 5G in the US, but we've got 4 tier 1 service providers that are all rapidly working to scale out this commercial product. Sometime focus on millimeter wave with Verizon and AT&T, although that's set to change in a big way next year as they introduce dynamic spectrum sharing to scale out coverage. Sprint's got their service in 2.5. And obviously Sprint, T-Mobile following a course for a merger that would allow them a kind of 3-tiered approach with 600 megahertz, 2.5, and millimeter wave. But the point of all this is, okay, so if you're an operator, is Open RAN going to make your job easier, or is it going to make it more difficult? So I posed that question to Nikki Palmer, Verizon's Chief Network Officer, during Mobile World Congress. And, this is what she told me. She said it is, very important goal that they're actively pursuing. She described it as their North Star, but she also talks about some of the issues that go along with this, which is interoperability and integration. Obviously that's a solvable problem, but when you think about a big tier 1 vendor undertaking a nationwide rollout of 5G, you don't want to slow down to focus on interop and integration when you can buy a full stack. So, she gets to the heart of the issue in this comment around interoperability and integration, but operators might not necessarily be the market entry point for Open RAN. So to give us a bit more perspective on some of the other opportunities around Open RAN and the enterprise segment, as well as what they're doing to commercialize this technology, I would like to turn it over to Ken Sanfeld, president of Solid.
Thank you. Appreciate it very much. It's an exciting topic and a great topic for sure. Just to kind of lead off of what you just said from Nikki Palmer. Solid's intentions in the market are to be that best of breed componentry. That's what we've been doing for 20 years, and we aim to continue to do that for another 20 years. So SURF is essentially extension of what we've been doing for 20 years in the DAS, amplifier, and optics market, and kind of follows the open standard market and the ecosystem approach. And it's the beginning, because it's essentially Open RAN, the Open RAN Alliance and whatnot has only been around for a few years now, but ultimately that is the standard that we are following. And it turns out that it looks like it's going to be the one that makes it. So you can go to the next slide. So real briefly, what does Solid hope to bring to the table with our SURF solutions? Ultimately, we solve many problems for the marketplace, but ultimately, it is an Open RAN architecture that allows for what the market is looking for, right? To mix and match network elements, both 4G, 5G, really importantly for in-building applications, multi-operator, and also needs to solve for commercial and private networks, and things like CBRS, of course. Indoor, outdoor. If the carriers are going to take advantage of the open architectures, they're going to be looking for every single piece of RAN equipment in the food chain, and they're going to look to find that best of breed, and that's going to be both indoors and outdoors, and they're going to scour the planet for the best they can find at the best prices and the best reliability. And of course, the solutions need to support sub-6 gigahertz, and as that changes and evolves, as new bands and sharing evolve, that will continue to evolve all the way through millimeter wave. Regardless of what our opinions are about, the effectiveness of millimeter wave or how it's going to work or how hard it is. It's a band that they're going to utilize, and we're going to make solutions that take advantage of that. So, the market focuses very heavily on the benefits to the network operator. So I'm not going to spend very much time on that. I think we all realize the benefits to the carrier, and it's very, very clear. I like to focus on the benefits to the enterprise because, in many markets such as the U.S. and in Europe as well, the enterprise is going to play a larger role because they are going to take part in solving for especially the in-building side of it, which is why there's a few key things that make that significant and what Surf brings to the table. It will be, the solutions will be multi-operator capable. They will be essentially end-to-end designed, so that if parts of it are operated by the enterprise, then those will be enterprise grade. The parts that are more carrier-centric will be set up towards what the carrier is looking for, which is usually that's going to be mostly in software. The enterprise is also looking for the speed at which these connections are made. The days of connecting a building solution and taking 6 months to a year is that's not going to work, right? Especially since we're talking about doubling, tripling, quadrupling the network density. We'll never get there, right? So making that faster, and that's going to be done through software. I joke about it in the market that it's, plug in a USB stick and go, right? So, and then of course, finally, the flexibility of being in the cloud or on premise. Obviously, edge compute dictates that a lot of that's going to be very close to the edge, but a big portion will be in the cloud as well. And so those are all key values that the Surf platform and Open RAN bring to the table. And then, of course, doesn't matter what kind of building or what kind of project it is, needs to be able to support all the bands that are available as part of the ecosystem of spectrum. So just to kind of illustrate the basic componentry of how it splits up, this is illustrating a very simplistic view, but it's very accurate in terms of how it goes together. So on the left side of the equation, you have both the centralized unit and the distributed unit, often called the CU and DU. In the case of Open RAN, it's called OCU and ODU. And that can be an LTE solution or an NR solution, and that is software on a COTS server. And so that's obviously, and that can be in the cloud or it can be on premise. And then with that, you have solutions that go to the right of that, either outdoor or indoor. And what I'm showing here is essentially a very simplistic indoor view, which is basically going into a front haul MUX, which is a Surf front haul MUX that allows you essentially to connect lots of elements, to a central server or to a switch. And then you also have an ORU. And now I'm showing something that's lower power in nature, but you might also have something that is, much higher in power to feed outdoor and macro type level of service. But in the end, it doesn't really matter. All of these parts are mix and match. Now, the reality of how that mix and match happens in the real world as the O-RAN standards are solidified is still to be seen. My guess is there'll be some proprietary elements here and there, but the goal is for there to be as little as that as possible, if not none. And that's the only way that it will allow this dream to happen. So just real briefly, some of the network architecture. I've already mentioned the CU and the DU components. Just take a quick note that they can be split up. They can be located in different places. It's very, very flexible on how the architectures can be put together. And once again, that's part of the beauty behind the open standard, is that you can modify the splits and where things go based on the situation that you're in terms of fiber connectivity to a site, and where you might have centralized CRAN type locations to locate other things. So the flexibility is paramount in how we can build a network, something we've never been able to do previously. This is just one other view. Once again, kind of laying into the flexibility. All the items in blue are things that Solid that makes, and ultimately the ability to mux things up, daisy chain, regardless of how the network architecture needs to look. The solutions need to be, flexible and support multiple types of layouts and configurations of the network. So the FHM, the front hole mux, is part of that architecture, and that's the solution that Solid makes as well. So this is a slide that I really like, and it essentially it's a very real world thing, right? Today we deploy DAS systems, right? And they look like the diagram on the top. The DAS portion is very self-explanatory. You go signal into a box, and then you distribute it out into a building. In this case, I'm showing our new fiber to the edge, fiber to the antenna solution. So but in that case, it's still a very traditional architecture. So what does that look? What does what does a O-RAN type of solution, in this case a SURF O-RAN in-building solution, look like? And this is what it looks like. Essentially, it's very, very similar. Basically, the big difference is that the BTS is split up into different components, the CU and the DU components. Ultimately, that makes up your BTS or your eNode B. What we're also showing here is that to do multi-operator, you're ultimately doing layers on the servers, multiple servers. You can do virtual layers, whatever you want to do, but you're putting multiple instances and layers to serve that. The rest of the architecture, is different in how it functions, but in the end, it's really doing the same thing. The goal is to get RF out to the devices to the end, right? The benefits that you get with with the architecture being O-RAN based is that you have the flexibility, you can scale very easily, you can support things like CBRS very easily, and you can do that on the DAS too. That's not a problem. You can support millimeter wave, something that the DAS really can't do. You have a low front end cost of non-proprietary hardware. And there's very little, if anything, required of physical access or physical equipment required by the network operator. So that lowers their cost and limits the amount of time that they ever potentially need to show up on site. They can just provide the backhaul and service. This is one other example I put in. Really, the difference between more of a DRAN architecture and the O-RAN side with SURF, and it actually in some ways looks very similar on the front end. With different operators having different BBUs to connect to their radio heads. In this case, you have different CU/DU combinations, and so I just wanted to point out the similarities. The benefits, of course, of going with the O-RAN are similar to what I just put on the other slide, but just for comparisons, I thought it'd be nice to look at how this compares to DRAN. And essentially, it functions very similar to a DRAN application. So finally, I'd like to introduce more of a hybrid solution. So, a lot of people say, well, there's no need for DAS anymore. And the reality is, DAS is not a four-letter word. It is absolutely a very simple solution that will be part of the toolkit for both network operators and the enterprise. Distributing RF is a very simple and proven solution, and in some cases it might be a better solution. So what the top shows is an example of a hybrid architecture where you have the carrier CU/DU solutions, or maybe even a private network CBRS type of CU/DU solution going into a switch. And in this case, I'm feeding the DAS with what we're right now, the name for that is the RFU, or radio frequency unit, radio RF unit. So essentially that is think of that as a solid piece of equipment that essentially is the base station, if you will, that's designed to drive the front end of a new generation of DAS solution. So it adds a lot of cool capabilities. It expands the possibilities for DAS. And and if that's the better solution, it allows you to do the same thing you're doing with ORAN on the left side. On the bottom, I'm basically putting the same surf architecture, the same ORAN architecture that that was on the previous slides, but I'm showing you a compare and contrast if you were to drive a DAS. So this allows, when you think about this, is really powerful. There are thousands of DASs across the country that are not being served by all the operators. These type of solutions hopefully will bring all the operators to those solutions, and that is something I hope and dream for the market. I think that's it's very critical that happen.
All right, Ken, well, you gave us a lot of commentary there on the benefits that Open RAN will have for the enterprise. I kind of focused my comments on the benefits that it would have for operators. So first off, I'd like to maybe discuss where those two sets of interest kind of intersect. One thing that stood out to me during your presentation was the benefit of a faster carrier connection. So when a Verizon customer, for instance, can't make a call from inside a commercial building, I imagine they call Verizon before they call their landlord. So if enterprises invest in these Open RAN technologies, it's a good thing for them and a good thing for carriers in that you can bring that signal source in as a software function and do it much more quickly than what you can now, right?
That's correct. Absolutely. Yeah. Yeah. I mean, it's a logical multi-operator and not a physical multi-operator, right? So today, when we say we want multi-operator in a building or anything, you're talking about bringing a piece of equipment in that's separate and different for every operator, and that's expensive for them, and not just to buy the equipment, but to put it in and go through all the paperwork, right? The backhaul is a given. That's obviously a given. That has to be there to connect to the network. But it's more of a logical approach than it is, physical, and that lowers cost and increases speed. And speed and connectivity is all the enterprise is looking for. Obviously there's some financial models and things that have to be looked at and different applications, but in the end, it's the speed of connectivity that every customer is ultimately looking for.
And then, in the other side of that whole notion of virtualization and software control, isn't that more IT-centric approach something that would appeal more to an enterprise owner than more traditional telecom gear?
Well, in the end, the enterprise, their enterprise owner of the system, they really just want to solve the problem, right? They're not network operators. To the extent we're talking about just commercial services with the carriers, they just need to make sure they're just trying to solve to make sure that all the operators can connect and they make it easy for them. And they want to purchase solutions that can work for them to support everyone, right? They're not too hung up on vRAN or otherwise. They really don't care, right? I mean, whatever goes the fastest, right? So, but I will say this, servers servers on site or connecting to the cloud makes more sense to an enterprise than putting special equipment in. Just like the infrastructure that goes in the building, what makes more sense to them is a cat cable or a fiber cable than does a half-inch piece of coax, right? That's been kind of proven for a while. IT guys understand how to pull structured cabling, necessarily understand how to pull half-inch cable and do PIM testing, right? So all these factors factor into the comfort factor that the IT department of an enterprise are going to have with a solution in their building.
So Ken, we started the webinar looking at some of the broad trends around Open RAN. It's certainly my perspective that this is gaining a lot of momentum right now, and I'm largely thinking about a lot of the conversations I had during Mobile World Congress in Los Angeles. I saw you out there. I'm curious if you could maybe give us a little bit of description about the conversations you had on Open RAN with some of your colleagues, competitors, customers, potential customers.
Well, sure. So, I mean, look, it's a movement. I mean, the discussion of open RAN architectures and how to make them work and mix and match. Mix and match is a common word. There's different depending on what country, and they have different words for it. But this is something that's a global thing. It's a global initiative. We're working with carriers in different countries to arrive at the solutions that they think are best. And so they're looking at best in breed, software. They're looking at different management systems and software. I mean, they're looking at hardware. They're looking at the whole ecosystem, and they're really trying to, piece things together and imagine how their vendor ecosystem is going to look. And that's I think what's really driving them is, they're looking at it saying, well, I'm not going to have one vendor or three vendors. I'm going to have potentially a dozen vendors, and how that goes together and how they do that. Kind of like Nikki Palmer said, it's both an opportunity and a pain point, right? So now they gotta work with lots of different people. So it provides an opportunity, but it also provides a situation where we've got to solve for the ecosystem, right? And so, the bottom line is the momentum is growing. I think another thing that's fueling it in the U.S. anyways, of course, is private networks and CBRS. That's fueling the open standard as well. There's a lot of CBRS products that are being built out there, and and they're all amazing. They're wonderful, cool solutions. But at some point, enterprise is going to look and say, well, I want to be able to buy different solutions from different people. I don't want to have one proprietary system that I have only one vendor and there's only one choice. If there's anything we can learn from the past, is that openness and flexibility are key, and that is the key to drive the system in the future and competitive in the competitive environment. And that's what that's really what this is all about. um, as much as it is to reduce costs per se. The cost part happens by kind of automatically.
Yeah. So I wanted to talk a little bit more about, I guess not just CBRS, but private networks as a market entry point for Open RAN solutions. It's something you and I discussed a little bit in a phone call we had, but just I think it's an interesting idea that, based on some of the operator commentary I put up on screen, it's not necessarily, that's not the low hanging opportunity right now. But you do have all this alignment around dedicated, shared, and unlicensed spectrum for these private networks going on in different geographies around the world. So how does Open RAN fit into that, Ken? You mentioned that enterprises need flexibility and they want the ability to pick the best solutions for their needs. But just if you could maybe put a finer point on why Open RAN is aligning nicely with what we're seeing with private networks.
Well, simply put, the private networks, CBRS, if you will, they're seeking innovation, right? And the innovation that they're seeking are, solutions that are both enterprise grade, which I would translate enterprise grade as the easy button. They want things to be simple and manageable and look and smell and feel like all the other products they buy from enterprise type vendors. And so the innovation that comes from the open architectures and the virtualization of those architectures, the innovations that come out of that are extremely powerful, and that's really that's really the opportunity that is happening, right? Do you need to have an ORAN based architecture to make a private network work or CBRS work? No, there's all kinds of boxes and things you can put together, and you can certainly build a network out of other components. The question really comes, is that going to provide all the functionality that people require? And I don't think we know the answers yet, because let's face it, we can count on not that many fingers how many projects have been done, right? It's just starting. We're at the very tippy edge of the opportunity that is private networks, especially in the U.S. And let's look at other countries. I mean, other countries, for example, Germany announced a chunk of spectrum that is going to be dedicated to enterprise. And I think that the U.S. has started a trend towards having an innovation band, and it's relating that back to Open RAN. I believe that the open architectures are going to drive the innovation that is needed in that space, and so that's how I view that.
And I think that kind of tees up a question that we just got from one of our participants, Ken. And, in the context of this private network opportunity, and as you said, we are at the early days of this. We've got the 3.5 here in the U.S. Germany's allocated 3.6, I believe. And regulators in other countries are at some point in that process, but do you see any regulatory challenges around spectrum availability as kind of slowing down momentum for addressing private networks, or do you think that the market opportunity will align with the demand and the availability of spectrum?
Yeah, no, absolutely. Great question. So, I mean, right now, everyone sees that we got, and let's just speak about the US. Everyone goes, well, look, we got this massive chunk of spectrum, we got no issues, right? I mean, I foresee some time in the future that we'll be getting to a point where, we have potentially a congested environment in the spectrum. Um, it's kind of hard to predict how that's going to roll out. I certainly have some concerns about that as soon as it really picks up. But I believe that, the whole idea behind CBRS and the SAS solution, the spectrum controlling solution, sharing solution, was really to mitigate those problems and, to provide a platform that was, stable and trustworthy. The FCC wants this to be a huge success, right? They want this to be the benchmark, and I think that it looks to be like it's gonna get there, right? So I don't think there'll be right now I don't think there'll be any more regulatory placed on it, but I think in the future there may be some things that come up with I think for the PAL licenses for sure. There's going to be things that come up there because to me that's not completely crystal clear on how that's going to work and how things will be handled.
So, Ken, this question isn't necessarily germane to what we were just discussing, but on your architectural overview, your diagram called out mid-haul as the connection between the CU and the DU. Can you explain what exactly mid-haul is?
Well, mid-haul is a term that was developed. If it's not on the front of the box and it's going in between those two solutions, anytime you have the split, the connection in the middle is typically referred to as mid-haul, and that's I don't know if that's necessarily a standardized term per se, but that's what I've seen utilized to discuss how to connect those boxes in terms of it. So it's typically going to be like an eCPRI type of connection, and because it occurs on the left side of some of those splits, it's referred to, or the middle is referred to as a mid-haul.
Ken, I also wanted to circle back to a comment you made about distributed antenna systems, that there's a need for them in the market and that it's a proven solution. Yeah, I hear a lot of kind of, I think, intentionally provocative commentary around how, DAS is dead. There's better stuff. And I guess from my perspective, given everything we've seen around virtualization and hybrid architectures, it seems to me that DAS is very much reborn as something new and is something a lot more dynamic than what the term might conjure in a lot of people's mind. But just maybe you could discuss with me a little bit about why DAS is not a technology that's on the way out, but something that's, very much flexible and able to address a lot of different needs.
Yeah, absolutely. I mean, let's first kind of talk about the root of why people say that. That people say that because they're proponents for the new technologies, and they advocate for the new technologies and how they go together. So does Solid. I mean, we advocate for all the latest technologies. However, However, we also are realists, right? And we know that the distribution of RF and the benefit of carrier aggregation and band aggregation, the ability to, for example, push 400 plus megahertz of spectrum on a single strand of fiber is something that it's just not possible with a lot of the new topologies, right? So there's things that you can do with a DAS that are just, it's going to take a long time to realize that, and potentially may not be cheaper than using a DAS. So I think it's going to be a toolkit approach. For example, the architecture that I showed up there earlier that you put up, which compared a DAS to the ORAN surf architecture, the difference is, pushing, like I said, 400 plus megahertz out to a antenna versus pushing 90 megahertz. Now, the argument could be made, well, hey, there's no need for that anymore, right? We're sharing spectrum, we're doing all these things, so, we don't have as many bands, and that's absolutely true, and that's why the ORAN architectures potentially will potentially win, or as I say, win. They're going to have a big place in the ecosystem. But there's a lot of applications where DAS is still very useful. In a lot of outdoor environments or venue environments, the DAS is still where you need lots of bands and use of spectrum. The DAS is still paramount in a lot of those applications because it's the best, most cost-effective way to get that RF there. And there's also the aesthetics issues. DAS and an antenna on the DAS, you can typically, shield that. You can put it in smaller spaces. If you've got to move all the electronics to the edge, and all the benefits that provides, unfortunately, that means a lot of equipment all hanging at the edge, which means it needs to be serviced. DAS systems are very, very reliable, almost never ever fail. And so, I know ours are in the below 1% failure rate. I don't think that a lot of the radio architectures are going to provide that, especially in hard to reach places and difficult environments. So there's just lots of examples of where a DAS is still going to be the solution of choice. I won't say that proponent of either. I think it's going to be what's the best examples that come up in the marketplace. And the other thing you got to remember is that the thing that's driving the cost on the ORAN, ultimately, the cost will drive down when we can go to silicon versus FPGAs, because right now the FPGAs are processing is going to drive up costs, are going to keep costs high until we can the systems will mature and we can drop the cost of those solutions, right? So I think both are going to be at play for quite some time. And it doesn't bother me that they say DAS is dead, because ultimately Solid makes all types of solutions, right?
So Ken, I have two kind of, I think, summary questions here that I'd like to end with. And, we've talked about operator and enterprise opportunities for ORAN. And to the operator piece, I talked about some of the action you've seen from the Vodafones and Telefonicas of the world. I know that you all are engaged with the ORAN Alliance, which is an operator-led organization. So I'm hoping that you can maybe just project forward to me based on your observations about the market, your conversations through ORAN Alliance and everything else, what you expect in terms of operator investment in Open RAN kind of near and midterm.
Well, I think what the operators are investing in right now is they're participating, everyone's participating in the ratification of the ORAN standards. And then the second thing that they're investing in is, starting to work with companies like Solid and various players to get those solutions in the lab and get some things, put together. For example, at Mobile World Congress a week or two ago, we showed an example of, with KT, where we showed the Solid solution, basically essentially an ORU DU solution combined with a millimeter wave RF solution from Movandi, and that same solution has been in a lab and is running and is proving the concept of the ORAN architecture, and that was deemed by KT as the first ever, world's first ORAN 5G millimeter wave base station, right? So that's the investment that they're making. They're feverishly trying to prove out the viability of the solution. The other thing that I think you're going to see them investing in and really stressing is the ability for these new network architectures to scale. Anyone can make something work in a lab and connect to 3 phones or 3 IoT to whatever, right, devices. But can you scale to 100,000 users or whatever the number might be? And that's what you're going to see happening is you're going to see them proving out the architectures, and you're going to see them prove out the vendors that are going to be able to make it happen and scale. I believe you're also going to see a lot of investment in acquiring companies. I mean, you got a lot of startups going on right now around 5G, and these startups are going to get acquired and be part of different companies. Some of them will be acquired by the network operators themselves, right? They're going to try to get an edge in the market on 5G, get an edge in the market on private networks. And I mean, they don't want to, they all want to win, right? So I see them making a lot of investments in that. You saw Verizon just opened up, or is going to be opening up, an R&D center, and a large center in San Ramon. They're investing because they need that those things to happen. So they need space, they need people and resources that are going to come in and work on those things. And I think we're going to see a lot of investment by all the players, especially the operators, to solve for these things.
All right. And then Ken, essentially, the same question as it applies to the enterprise segment. I'm just kind of curious, as you all get your product ready and mobilize your sales force to start taking this in front of enterprise buyers, what do you plan for the next 2 to 3 years? What's the outlook around Open RAN?
Well, I think the outlook for Open RAN right now in short term for the enterprise is obviously private LTE CBRS based, at least the way we see it, right? That's where we have the opportunity to develop solutions that are enterprise grade and friendly. I think that what we're going to see over the next year, the next year is going to be people trying to prove out their ROI formulas, right? So every vertical is going to find their little applications of how it's going to make them money and save them money, right? And in order to do that, they're going to need us. They're going to pick a vendor that can put it all together and show them how to make it work, right? So those things are going to happen, and the number of projects is going to multiply very quickly as people try to prove it out. And that's exactly what's going to happen in 2020 is continuation of proving out the solution. Over the next 3-4 years, I think what's going to happen is the key applications that boil to the top and create the most ROI, whatever those may be. We can talk for the next 2 hours about all those. Those are the ones that are going to drive the market forward. They're going to float to the top, and there's going to be use cases and applications that we just really haven't even figured out that are going to pop up, and they always do. And just like people found out all the use cases for 4G over the years, right? So we see 2020 as a lot more trials, a lot more experimentation. We see the carriers, of course, wanting to watch that carefully, because let's remember, the carriers don't want to lose the IoT business to private networks, right? The IoT was supposed to give them more, revenue back, right? Maybe it's only $1 a month per device, but IoT was supposed to be a way for revenue to come back to the carriers and not go elsewhere, So I think we're going to see the carriers, really pushing hard to grab some of their enterprise business as well, which is why we continue to work with the carriers extensively on CBRS. But the enterprise guys are going to be really trying to prove out their applications and use cases. And I think it's going to be super exciting to watch, and it's certainly a great space to be in as we see it. I think it is going to be, it's going to be years in the making, not months, right? I think that it's going to take some time for it to kind of shake out. But my prediction is it's going to be a big deal. I think it's going to continue to be a growth segment in the market as it shakes out.
Well, Ken, I think that's a great observation. I tend to agree with you. For operators and for enterprise, it seems like we're on a pretty steep ramp as it relates to ORAN. So I want to thank you for taking the time to join me for this conversation today. And I want to thank everybody that participated in the webinar. As a reminder, you're going to receive a companion report that goes into more detail on some of the topics Ken and I discussed today, as well as a few others, including RAN optimization, service assurance, and extending virtualization from the core out to the RAN. So be on the lookout for that. And also, we will make this webinar available on demand on our YouTube channel. So Ken, thank you again for your time today.
Thank you very much.